In this video, we'll be looking at a problem based on permutation and combination, and this problem involves a lot of higher order thinking. So what I'll be doing is, before I tackle this problem, I'll be going through the basic concepts of combination and permutation, or anything with probability that we've learned so far. So if you've watched my previous videos and you're already familiar with the concepts, then you can skip this part. But for those who are new, or if you need a recap, you can just stay around. Okay. So first, I'll tell you the difference between combination and permutation. Now, when do we use combination and when do we use permutation? Because it can be confusing sometimes. Let me give you a question as an example. There are 10 men and it's needed to form groups of 3 from these 10 men. Now, how many possible combinations are possible? In this case, we use combination. We use the combination formula. Why? Because the order of the 3 men who are chosen does not actually matter. Like, I have 5 fingers. I can choose these 2 or I can choose these 2. The order won't actually matter. It does not matter whether I choose this first and then this, or this first and then this. The main objective is for me to choose 2. Likewise, over here, out of 10, it doesn't matter in which order the person is choosing the men. So, in this case, we use combination. So, in combination, order does not matter. Now, let's go through the formula for combination. NCR can be expanded to write n factorial, n minus r factorial and r factorial. Now here n is the 10 men, the total number of men, and r will be 3 because we are choosing 3 out of 10. Okay, so this will be 10 factorial by 7 factorial and 3 factorial. This is the formula for combination. Now let's look at permutation. An example of a question for permutation will be, let's say there are 10 letters of the alphabet and I am choosing 3 letters to form a word. How many possible combinations are possible? In this case, if I am choosing A, S and D, these are 3 letters, but I am choosing A first. So A goes here, then I am choosing S. Then I'm choosing D. So this is one word. It's not actually a word, but just an example. ASD, it's a word. Then I can also choose it in another way. I could have chosen S first. It's the same 3 letters, but I could have chosen S first and then A and then D. We have another word. Or D first, S and A. That's another word. So I hope you get what I'm saying. I'm trying to say. What I'm saying is, the order of the letters that I choose actually matters in this case. So in this case, order matters. Why? Because he states that he wants to form a word. So order matters. And the formula for permutation is NCR, which can be expanded as n factorial and r factorial. So this is the difference between the formula of combination and permutation. I'm sorry, this is supposed to be P. NPR will be n factorial by r factorial. So this is the gist of permutation and combination. Now let's look at the basic formula for probability. What is probability? Probability can be expressed as the number of desirable outcomes divided by total number of outcomes. Now, desirable outcomes means total number of outcomes is the sum of all the possible outcomes that can happen in an event. For example, if I'm rolling a dice, the total number of outcome will be getting 1, 2, 3, 4, 5 or 6. Why? Because the dice has 6 different faces, 6 different sides. So I could get any of these outcomes. So the total number of outcomes will be 6. Desirable outcome will be stated in the question. For example, the question could state that find the probability of getting a 3. Getting 3. So it will be in this particular structure, or what is the probability of, and then this will be the desirable outcome. So in this case 3, it's only one possible outcome. Out of these 6 outcomes, this is only one. So the probability is 1 by 6. If the desirable outcome is find the probability of getting a multiple of 2, then it will be this, this and this. So there are 3 desirable outcomes. So this will be 3. So now let's move on to the problem. Now this is a type of problem that they ask in product-based companies. So let's look at it. There are 2 classes, class A and class B. Class A contains 5 girls and 3 boys. Class B contains 7 girls and 6 boys. 2 students are transferred randomly from class A to class B. Then a student is randomly chosen from class B to represent the class. Find the probability that the 2 transferred students are boys if the student chosen to represent the class is a girl. Okay, so this is a lot of information, but let's solve it step by step. What we'll be doing is, first you have to realize that there are 2 events happening over here. It's not just one event. Rolling a dice and getting a number is one event, but there are 2 events. First event is 2 students are transferred from A to B. Right? That's one event. Then after that a student is chosen, so we have to find the probability of that first. Then after that a student is chosen randomly from class B to represent the class. This is another event. So they want you to find the probability that the 2 transferred students, these 2 students who are transferred from A to B, are boys. If the student chosen to represent the class is a girl, the student who is chosen randomly, if she is a girl, what's the probability that the 2 students transferred randomly from A to B are boys? Okay, so let's tackle it event by event. What's the first? Let's look at the number of girls and boys. In class A, there are 5 girls and 3 boys. In class B, there are, just give me a minute, there are 7 girls and 6 boys. Let's look at event 1. The first event that happens is 2 students are transferred from A to B. Right? Transferred from A to B. Now this particular event has 3 different possibilities. First possibility, both are girls. Both of these transferred students are girls. That's a possibility, right? We have another possibility, that is both are boys. We'll have that as E2. This is E1. Or it could be that one is a girl and one is boy. Any of these 3 possibilities could have happened because 2 students are transferred from A to B. Sorry. Okay. So what's the probability that both of them are girls? Let's look at the formula for probability. Probability is equal to total number of outcomes, desired outcomes by total number of outcomes. First, let's look at the total number of outcomes. 2 students are chosen from class A. How many students are there totally? 8. So from 8 students, 2 are chosen. Right? So now let's look at the desired outcome. The question is stating that, not the question. This event is that both are girls. So what is the probability that both the students chosen are girls? So if both are girls, it has to be chosen from this 5 girls. Right? So from this 5 girls, I have to choose 2. This will be only if I choose from these 5 will I get a desired outcome. The total number of outcomes is randomly choosing 2 from all 8 of this. But the desired outcome will be when it's chosen from these 5 girls. So this is the desired outcome. This is the total number of outcome. Now this will give me, let me write this clearly. We have 5 here. Here. Now this will give me 10 by 28. You can calculate this by yourself because this problem is so huge, or else I'll calculate it on the side, but this is just so huge. So I have to go on. So this is 10 by 8. What is this? This is a probability that both the students who are chosen to be transferred from A to B are girls. Now let's look at the probability that both of them are boys. Total number of outcomes will be the same as this. There are a total of 8. From that, 2 are being chosen. Let's look at the numerator. If both of them are boys, then they have to be chosen from this. This 3 boys. Only then will it give a desirable outcome. So it will be 3C2. And this will give me 3 by 28. Now let's come over here. One of them is a girl and one is a boy. And okay, so it will be the same. I'm choosing 2 from a total of 8 people. But here, one is a girl. Let's first look at one of them is a girl. If one is a girl, I'm choosing 1 from this 5. Into, why? 1 is a girl and 1 is a boy. Like I've always said before, in every single one of my problems, you have to look at whether the 2 events is connected by and or. And or. If it's and, you have to multiply. If it's or, you have to add. Here it is and. It's a girl and a boy. So it will be, for boy it will be, you're choosing 1 from 3. On calculating this is just multiplication. So on calculating it, you will get 15 by 28. Okay. So now I'll be erasing all of this working space so that we can move on to the next problem. The next section. This is probability that both are girls is 10 by 28. The probability that both are boys is 3 by 28. And the probability that one is a girl and one is a boy is 15 by 28. Okay, now let's go on. The question states that a student is randomly chosen from class B to represent the class. Now we'll go on to class B. So they're choosing a student. These 2 students have been already transferred. Now A is out of the picture. Let's look at B now. One student is chosen randomly from class B to represent the class. And the question also states that the student who is chosen to represent the class is a girl. Okay. Now let's look at this event. If both of the students, if event 1 had happened and both of the students who have been transferred from A to B are actually girls, then how many girls will be there in class B? It will be 7 girls plus the 2 transferred girls, which will be 9 girls. Now you'll have to pay close attention to this part because all 3 of these events will lead to different number of girls and boys. Because in this event, boys are transferred. Here 1 boy and 1 girl. So the number of girls and boys will be different in all 3 of these events. So just pay close attention. Here we have 9 girls and 6 boys. Here we have both of them are boys. So it will be 7 girls and 8 boys. The boys will increase by 2. Next we have this event where one is a girl and one is a boy. So we'll have 8G and 7B. 8 girls, 7 boys. Right? Now let's proceed. The question states that the student who's chosen is a girl. So what is the probability of choosing a girl from this? Probability will be 9 out of total number 9 plus 6, which is 50. This is the desired outcome, total number of outcome. Total is 15 and 9 girls are there. So the probability of choosing a girl is 9 by 15. Why are we finding the probability of choosing a girl? Because the question states so. A student is randomly chosen from class B to represent the class. The student who is chosen to represent the class is a girl. Right? It's like, this is actually a condition that the question gives. This is a condition that we have to fulfill. So we cannot look for boys. It has to be a girl. Using that condition, we have to find the probability. In this case, the probability of choosing a girl will be different because the number of girls and boys is different. We'll have a total of 15 as in this case, but the probability will be 7 by 15. Here it will be 8 by 15. Okay? So these are the probabilities of choosing a girl. Now we have two probabilities. What do we do with these two probabilities? Do we add it or do we multiply it? Both of these probabilities happen. This is event 1, right? And the second event is I'm sorry, I didn't mention that. Somewhere around here, I should have inserted event 2, and that is choosing one student randomly from class A and B. And that student is a girl. So what is the probability? That is event 2. Now both event 1 and event 2 happen. Both of it happen. It's and. So what do we do with these probabilities? What is the probability that event 1 and this event happens? It will be 10 by 28 into 9 by 15. It will be multiplication. Likewise, first 2 boys are transferred, that is 3 by 28. Then after that, one girl is chosen from class B, that is 7 by 15. So total probability will be 3 by 28 into 7 by 15. This case, probability of choosing one girl and one boy from class A is 15 by 28. And the probability of choosing a girl from class B to represent the class is 8 by 15. So we'll have this as the probability. I have found out this the product of all of these fractions. This is 3 by 14. This is 1 by 20. And this is 2 by 7. Let me just double check it. Give me a minute. Yes, so we have the 3 probabilities. Yeah, okay. Now let's look at the question. We have even this and this 3 probabilities. I will be just erasing this part. Okay. Now look at the question. Find the probability that the 2 transferred students are boys if the student chosen to represent the class is a girl. What's the basic formula of probability? It is number of desirable outcome or favorable outcome by total number of outcomes. What are the total number of outcomes over here? This is a particular outcome. This is an outcome. This is an outcome. These are the 3 outcomes that could happen. This whole set of events will lead. it was 3 by 14, right? This whole set of events will lead to this collective outcome, or this whole set of events will lead to this outcome, this probability, and the probability of all of these events happening is 2 by 7. So these are the probabilities of this set, these sets of events happening. So the total number of outcomes will be 3 by 14 plus 1 by 20 plus 2 by 7. Now you could ask me, why is it plus and not multiplication? Y means this whole set of events, or this whole set of events, or this whole set of events. Any of these three sets of events could happen. It's or. So we add it. Now let's look at the desirable outcome. What is the desirable outcome? The keyword is probability. Whatever comes after probability, find the probability that this will be the desired outcomes. And that is, the two transferred students are boys. This is the condition, and this is the desirable outcomes. Two transferred students are boys. Now, which one of these three sets of events has both of the transferred students as boys? It is E2, 1 by 20. So we have 1 by 20 divided by 3 by 14 plus 1 by 20 plus 2 by 7. I have not calculated for this. I have not calculated the fraction, so I will do it now. We can have it as a total of 140 because that's the only common denominator I can see now. So here we will have 1 by 20 by 40 into 7. This will be into 7. 20 into 7 is 140, right? So this will be 7 by 20, and then we have this 1 by 40, we'll have 30 plus into 7, so 7 by 140 plus into 10, 20 by, I'm sorry, not 10. This will be into 20, so we'll have 40 by 140. And this will give me, on cancelling all of the denominators, I'll have 7 by 30 plus 7 plus 40. It's a weird fraction, but this is the answer. We have 77. So this gives me 1 by 11. So 1 by 11 is the probability that both of the transferred students are boys, with the condition that the student chosen to represent the class is a girl. So I hope you could understand whatever I had told all this time. If you want more questions on this type in a more elaborate way, or just of this type, please subscribe to my channel. Thank you.